we're asked to solve the equation sine of 2x equals minus sine of x for x values between 0 and 360 degrees. So our main impediment right now is that we have a mixture of angles in our trig functions, which are tricky. So we're going to use the trig identity that sine of twice theta is twice the sine of theta times the cosine of theta. Or in our equation, we replace sine of 2x with 2 sine x cosine x and set that equal to minus sine x. And then you might be tempted to divide through by sine of x on both sides, but as we've said several times in class, that's potentially risky because sine of x could be 0 and you can't divide by 0. So instead we're going to do the much safer way of doing things, which is to bring everything to one side and use what's called the 0 property. So we add sine x to both sides and we get that 2 sine x cosine x plus sine of x equals 0. Now we can factor out a sine x from both terms and leave on the inside 2 cosine x plus 1 equals 0. Now we use something called the 0 property, which is really as simple as saying that if two numbers multiply to give you 0, then one or the other of those numbers must be 0. So we have either sine of x equals 0, or we have 2 cosine x plus 1 equals 0. In the first case, we get x equals 0 degrees or 180 degrees. And in the second case, we have 2 cosine x equals minus 1, or cosine x equals minus a half, which implies that x is either 120 degrees or 240 degrees. To get all the values for cosine x equals minus a half, we go through the reference angle, which we can find by taking cosine of r, our reference angle, is plus a half. This tells us that r is 60 degrees, the acute angle that has cosine equal to 1/2. So we now need things that have a reference angle of 60 degrees, but the fact that we have minus a half over here tells us that we are in either quadrant 2 or quadrant 3, because those are the places where cosine is negative. If we're in quadrant 2, then our angle looks something like this, and since we know that our reference angle is 60, our actual angle needs to be 120 degrees. On the other hand, in quadrant 3, we look something like this. This is our angle. We know that our reference angle is 60, and so our actual angle, which is 60 degrees more than the 180, must be 240 degrees. And that's how we got those two guys. We can confirm our solution by plotting the two functions and then seeing where they intersect, because intersection on graphs is the same as equality in algebra. So we pop over to Desmos, then we graph the two functions. Following the colors above, we'll plot 2 sine x cos x in blue and minus sine x in green. We see pretty quickly that we have intersections at 0, at what is believably 120, at 180, and at 240, exactly as predicted. So these are our solutions.